Morning. I guess we are starting the show. I guess you guys are here because I guess you are interested in mobile apps, so that's great. Me too. So for this talk, we will focus on two things. I guess most of you are here for reversing or how to audit these kind of apps, or maybe how to secure them. So I will give you some tips about from both sides. So this talk is going to be about mobile cross-platform technologies, about different frameworks for the mobile phones. So my name is Simon Roses. I'm the founder of a cybersecurity startup back in Spain. And here you can have my contact details. Oh, I'll be here through the conference. So if you have any questions, you can also come and talk with me. So the objective. I don't know if we should close this door or not. Okay, the objective for the talk. So we will talk about the different frameworks for mobile cross-platform technologies. I mean, there are many. I think there are around, at least I have a count around 40 or 50, and I'm sure I have not got into all of them. So I will just focus on the top mobile technologies, cross-platform technologies, right? Like 4, 5, 6. We will try to answer a simple question. Is these technologies are better or worse in terms of security? So we will try to answer that. And of course, we will also go into how we audit those kind of technologies, or those apps, right? So the agenda is we are going to talk about the different platforms, what different frameworks we can use to develop apps, mobile cross-platform apps, so one app that works on different platforms. We will go into details how this technology, all these frameworks, cross-platform technologies work. We will talk a little bit how we audit these apps, and then we will do some conclusions. So too many platforms. I mean, I guess you guys are familiar, right? I mean, right now it's a madness. I mean, we have the leaders, of course. We have iPhone, Android. Android probably is the top mobile platform in the world at the moment. But now we can see that the contenders, right? There are many more platforms that has been showing up lately. I mean, BlackBerry is trying to come up again to be one of the leaders. It's not at the moment. We have a Windows Phone. We have also Firefox OS, Tizen, Selfish. So there are different mobile platforms. I mean, for example, if I want to develop an app, chances I will go for iPhone or Android because those are the most popular platforms at the moment, right? But that doesn't mean that tomorrow maybe any of those apps, any of those platforms is going to gain market share. So that means I have to also focus on those platforms as well. So from a developer standpoint of view, this can be a madness. You have to develop a single app for each platform. So in the last several years there have been several options trying to address this problem, and this is what we are going to talk about in this talk. So the price. I mean, as we have just seen, there are different platforms, and the cost of developing apps into this platform is quite expensive. For example, we have coming up with these numbers is a bit tough. I mean, I was able to do some numbers from these sources. So you can just go to these different links and get you an idea of the numbers. I mean, but for example, looking at the different sources, I was able to come up with these numbers, and we can see that a simple app is like between $6,000 till $50,000. So that's quite a lot of money just for one app, if we think about it. I mean, a simple app is what they call like a mobile app with just maybe internet connection and a few screens. That's it. Then we have medium apps, medium application. It can go from $50,000 to $150,000 US. So that's quite a lot. And a medium application is what they consider with database support, connecting to web services. So it's more complex. And then we have the really complex apps, and usually those are games. And usually the price starting to develop those apps is around $150,000 more to develop complex apps. And so if we think about it, if I'm a developer, I have to develop an application for each different platform using these numbers. It's going to be quite expensive. So we have to look for different options. So here is where people are coming up with some solutions, right? The traditional development of applications is in Android. We develop an app using Java and XML, and that application is for Android. That's fine. Then if we want to develop an iPhone, iOS application, we use Objective-C. Okay, that's fine. And you can see there are very different skill sets. I mean, chances are you have different teams to develop Android apps and iPhone apps, so that's why that can be quite expensive. So they have several vendors have come up with options, and you can see here we have the cross-platform technologies. So now we have different options we can choose to develop apps that will work pretty much on any phone. So that's quite convenient. Right now we can have just one application that works in different platforms. We have the Simian project in .NET, and actually it's quite nice because it's the people behind the Mono project that support this technology. So now we can write a .NET application that works on Windows, iPhone, and Windows Phone and other platforms as well. So that's pretty neat. So now we can have just one application that works pretty much in that's the theory. Actually, in reality, it doesn't work that well, but pretty much you can do this thing, right? Just one application pretty much will work in all the platforms. Then we have the Corona SDK, and you write an application with Lua language, work on Android and iPhone, quite nice. We have PhoneGap, very popular framework. So we just write mobile applications, apps, like web apps. So a mobile app becomes a web app using PhoneGap. So we write applications using HTML, Cascade Style Sheet, JavaScript. Actually, we can see that many web developers are choosing this framework because it's the same thing like writing a web app for the mobile phone. So it's becoming quite popular, and you can write application for Android, iPhone, Windows Phone, so it's quite convenient. And then we have another Raw Mobile. The same thing, you write applications using Ruby and JavaScript, HTML, Cascade Style Sheet, so it's quite convenient. So it's also like web application using Ruby and HTML, so it's quite nice. And it also works on Android, iPhone, and Windows Phone. So we have different options. Those are in my opinion at least, from what I have been seeing, those are the most popular mobile frameworks at the moment. I mean, there are many more, but those are the most popular right now. And those are the technologies we're going to focus in this talk. So from a more reversing point of view, so if you guys are used to do reversing on mobile apps and doing audit of this kind of apps, the traditional way we use like tools like APK tool, Dex2Jar, GDUI, IDA for iPhone or whatever, Hopper, another disassemble, quite nice for iPhone. So we have different tools, right? But now for this kind of mobile technologies, we have also to include new tools. I mean, they are not really new. We are really familiar with those kind of tools, but we have to keep those tools in mind in our toolbox for mobile. Before, we just focus on Android and iPhone apps. But now we have to include these new tool sets as well in our toolbox when we are doing mobile reversing. So now we have to think about .NET decompilers, Ruby decompilers, a bit hard, and we will talk about it. JavaScript, static analysis, there is a lot of JavaScript in apps, so we want to review those files. And also we will also write some custom tools, and I will show you why we want to do that. So now we have so now our toolkit is expanding to include all these things. I mean, things we already know, but we have to include it in the mobile toolbox kit, right? Okay, so the technologies. Let's focus on the cross-platform technologies. In this talk, I will just focus on these 6 frameworks. We will talk about the basic for Android, PhoneGap, the Corona SDK, Raw Mobile, and Monodroid Monotouch. I mean, Monodroid Monotouch is pretty much the same thing. It's the same company for .NET, but they have separated into products. Actually, you can just, for example, you can just develop for Monodroid or you can just develop for Monotouch. So that's the reason I have also put it in separate categories. So we will focus on those mobile technologies, but if you go look around, if you do a Google search, you will find many more frameworks about mobile. But I think those are the most popular frameworks at the moment. So that's the things I want to focus on. So Basic for Android. This is quite interesting. I mean, honestly, basic for Android is not that popular, or at least I have not seen it that much. But I think it was kind of cool because, I mean, it's basic is back. I mean, I don't know you guys, but I remember when I was a kid developing basic application. This is back. Now you can write basic code, basic application for the mobile. So that's kind of cool. And basic for Android allow us to write basic apps that works on Android and in desktop, like in Windows platform. So that's quite nice. We can write a basic application and what it does is, we use the basic development framework. We write our application basic, and it will get translated to Java code. So that's kind of nice because now we don't have any dependencies or native code. We will see that with the other frameworks, there's a lot of requirements and native codes and libraries. So your application gets a little bigger when you use mobile technologies, cross-platform technologies. But in case of using basic Android, your application is quite small in size, and there's no any native code or anything like that. So one other thing is basic for Android includes like 33 Java libraries. For example, I'm writing an application using basic that connects to internet or reads from a database or whatever. When it gets compiled and translated to Java, then the development framework will include those libraries to connect into the internet or network library and database library and all that stuff in Java. So my application gets converted from basic to Java, and it will include all these Java libraries in the app. And here we have an example. So, for example, here we have some just basic. We are creating an activity. So you guys are familiar with the Android development. So we are creating an activity and just putting a message box. And this is basic. And we are in the development framework and the basic for Android. So we write our application. And when we compile, this application gets translated to Java, and then it gets run in an Android. And this is the workflow of a basic to Android application. So pretty simple. Okay, one of the things we have to think about is the permissions, mostly in Android platform, right? In the case when we write basic for Android applications, we get like four permission by default: internet, Bluetooth, write external storage, and Bluetooth. Chances are Bluetooth you don't need that, and the reason it's enabled by default is because the development environment can connect via Bluetooth to your device, to your phone, to upload applications, and that's the reason it gets enabled by default. But chances when you develop an application, you will not need Bluetooth. But for example, and another thing quite interesting with basic for Android is write external storage permission. And one thing we have, when we are reversing all these applications for basic for Android, we have seen that all the applications using this framework write information to the SD card in the Android. So that's kind of interesting. So that's the reason it gets enabled by default. They write external storage, but because all of them save information to the SD card. In some cases, there was like sensitive information, and in other cases, it was general information. But so far, we have seen that all the applications for basic for Android write information to the SD card. So, for example, if you are doing a review for a basic for Android application, you have to keep in mind you have to take a look on the SD card to see what kind of information has been saving there. One of the good, cool things I think about the basic for Android is that it offers like obfuscation feature, so that's quite nice. You can obfuscate your application. I have not tried myself because it's only for the commercial version. You can download a trial version, and that's the one I have used. So I didn't have the chance to test it. But from the documentation, it says that it performs like string obfuscation and variable renaming, so that's nice. So at least that's a start. I mean, it's not that hard to bypass, but it's something. I mean, we are adding more protection to our application. But I think it's quite neat that the development framework offers these features in the IDE. Okay, so now moving on to different frameworks. We have just covered basic for Android, pretty easy, and now we're moving to PhoneGap. PhoneGap is very popular. We can write applications using just HTML and Cascade Style Sheet and JavaScript, so it's like writing web apps in the mobile, like a mobile app. It supports a lot of platforms for Android, iPhone, Windows, BlackBerry, Bada, WebOS, and it's getting a lot of more platform as well. And actually, this is pretty much, from what I've seen, this is one of the top mobile cross-platform technologies. I mean, there are many apps using PhoneGap. Chances are sometimes maybe some applications you have installed in your device maybe is in PhoneGap, maybe. But there are quite a lot of applications right now in the market using the PhoneGap. So it's just like writing web app in your mobile apps. So it's quite nice, and there is a lot of web developers using this technology because they are familiar with all these kind of technologies, right? So here we have just a simple how this PhoneGap works. So when we write an application in PhoneGap, it gets compiled into the platform, and Android, iPhone, whatever platform. What it does, it creates a binary for the platform, and this binary will run all the different things it needs. It will load and run read the config XML. Config XML is a PhoneGap configuration file, and we can see that different configuration parameters of the application in that file. So when we are doing a review, we want to review that configuration file, and there we can find the plugins, what plugins is the application using, and different permissions and whatever. And then we also have the files and folders for the application. For example, I'm doing a PhoneGap for Android, PhoneGap for iPhone. I will get folders and files for the Android or for the iPhone app. So we get that. But we can also get another folder, and that's the folder we're interested in. We're getting the www folder, and that's the entire application. So when we write an application using PhoneGap, the entire application goes here. So all the JavaScript, Cascade Style Sheet, HTML is here. So we can see we have all the application logic in this folder. So that's quite interesting. So we want to review this here. We can find the entire application here in this folder, and this is the place we want to focus on. One of the interesting thing about is that in the case of PhoneGap, it requests a lot of permission. Even when you go to the documentation, it recommends to allow all these permissions in your app. So it doesn't make sense at all, but that's what the documentation says. For example, when we were reviewing several of these apps, actually PhoneGap's application pretty much work with the internet permission. That's pretty much the only thing you will need. Well, it depends what your application does. But with the internet permission, your application works fine. But even in the documentation, it recommends to use all these permissions. So I guess the people the PhoneGap people have to change this and make some much better recommendation about what permissions do we need, right? Chances are we don't need all this permission in our application, but this is what the documentation says we should use. Okay, so moving to the Corona SDK, here we use Lua language to develop applications. We can use Lua to write mobile apps. And this application will work on iPhone, on Android, Kindle Fire, Nook. So from what we have seen, it's quite popular in the game community. I guess Lua is quite strong because there are several games using Lua for scripting. So I guess it's quite popular in the games. So we have seen that pretty much all the applications that use Corona are mostly games. But some of the really cool, if you look in the market, some of the popular games with millions of users, they are using, for example, Corona. So that's quite interesting. And how Corona works, and this is the structure, right? So again, we are writing an application in Lua. It gets compiled into the different platforms, and it also creates a binary, and this binary will upload the resource.car file. And here we can find the entire Lua code for our application. So when we write an application using Lua, everything will go into resource car.file. Everything gets into that file. Then we also have the platform files and the folders for the platforms, and some miscellaneous files. And it depends what type of files and images or whatever files the application is using, so you can also get those. And in the case of an Android application, so for example, if we are using Corona in Android, we also get another folder, the lib folder. And here we have the lib Corona library and lib Lua library. You can see those at the bottom. And those are, and this only applies to Android. This is what the Corona framework needs to run Lua applications in Android. In the iPhone, it doesn't do that because it puts everything together in the binary. So everything it needs is in the binary in Android, in the iPhone. But in the Android, it also creates some libraries to run Lua applications in the mobile. So that's quite interesting. When we are performing a reversing, we can find those libraries. And maybe we can also look for security bugs there. So in the case of the permissions, in the Corona, actually it's quite good. Only one permission by default, so that's start. In this case, only that when we create a Corona application, only one permission by default, internet permission, that's fine. So we have also like ROMobile. ROMobile, another framework, is becoming popular because it's supported by Motorola, so it's getting like a lot of support. And here you do the same. You write like web apps using like Ruby and HTML, JavaScript, and Kafka style sheet. So it's quite interesting. Also works in Android, iPhone, Windows, and Windows Desktop and Windows Phone. So it's quite nice. We can write a simple Ruby application with HTML, JavaScript, and it works on different platforms. So right now we have seen that it's very limited in the number of apps using this technology, but it's improving because as I said before, I mean, Motorola is pushing for this technology, so it's getting a lot of attraction. I guess it will take just some time to all these frameworks to get it more unpopular. Just, I guess, matter of time. In terms of the structure, here it looks like a bit more complex, but it's not that hard, actually. And for example, what it does is we have, for example, an application written in ROMobile. For example, if we have an iPhone binary, it creates a binary. In this case, for example, before, you guys saw, I always put platform binary because the names can be something, the application name. So I don't know the name, but here it's different. ROMobile use the same binary name. So for example, for the iPhone, for the iOS, it will be always the RoRunner binary. So that will be always the name of the binary for ROMobile applications. And then for Android, it will be roads, right? So those are always this framework always use those binary names to run the application. So it doesn't care about your application name. It always use those binary names. So here it will create several folders. In the case, for example, for Android, we have a lib folder, and again, it will put a lib roads library that will need it to run the ROMobile application, the Ruby bytecodes. And it will also create some lib folder, a general lib folder, and the lib folder, the one in green there, what you can find in this folder is an entire Ruby bytecode for the ROMobile framework. So here we only find like all the libraries the application needs from the Ruby framework. So it's not part of it's not the application you have to write. It's just the libraries you need from the framework. But the ROMobile will put all the libraries in this folder. Then we have the apps folder, and here we can find the application we wrote. In the app folder, we can find the Ruby bytecode for the application. So here we can find all the application logic. And then we have also the public folder, and here we can find the HTML, JavaScript, Cascade style sheet code. So now we have the Ruby bytecode in the app folder and the HTML, JavaScript in the public folders. And those are the places we want to look for. And then another interesting feature here is we have the raw config txt, and that's a configuration file for the ROMobile, and we will cover it, and we will talk about this file, configuration file, in a little bit because we can find some interesting things. And then we have also the DB folder for some database features for the framework. And then we also have the platform files and folders depending on your application, right? So it looks a bit more complex, but actually it's not that hard. It's pretty much the same as the other frameworks. The only thing is it puts much more stuff into your app. Okay, in terms of security, it's quite nice because you offer different things. By default, it will not give you any permission. So it's up to the developer to define what permissions it has to declare. So that's quite nice. I don't get anything by default. It forces the developer to choose the permission it needs. Hopefully, he will choose the minimum. Hopefully. Not always the case, but that's what we are hoping for, right? And another thing is he also offers the security token, so quite nice. We can restrict access to the application. So the application will not run unless we submit a security token. So that's an interesting feature we can add to the applications. And also the development framework also offers a JavaScript and Cascade style sheet obfuscation. So it's quite nice. Our Ruby application gets translated to bytecode, and our JavaScript Cascade style sheet gets obfuscated. So at least we have like different level of security for our application, making reversing a bit more harder, right? So that's quite nice that these guys are thinking about security. Now we are moving to Monodroid. Actually, Monodroid is becoming very, very popular because it's from the Mono project people. So it's getting a lot of attraction. There's a lot of .NET code written, right? So now you can just take all your C# code and make it mobile. So that's quite convenient. So there is a lot of people taking all this .NET code they have and making mobile apps. And using Monodroid, we can write a .NET application that works on Android. Actually, here it says it works on iOS, Android, Windows Phone, and Mac OS. And actually, what they do is it depends. Monodroid is specific for the Android, and then they have Monotouch specific for iOS, and then you can also get a Mono for the Mac OS. It depending what platform you want to develop, you have to get a different license from these guys. But it's quite nice, and this is becoming quite popular. So here we have an example. I don't know if you guys in the end can read it, but I guess when you guys take a look on the slides, you can get the code. But here is quite a very simple example. And here we have a .NET application that usually is just show us a button. When you click the button, it will pop up a message. That's it. And this .NET application gets translated into in this case, an Android application, and the same for the iPhone. We can take the same code and translate it, and it gets translated to iPhone. So it's quite nice. If you are a .NET developer, it's very excellent because now you can write your .NET application for different platforms. So that's quite nice. In terms of how this works, again, we have a platform binary, and this is specific for Android. So when a Monodroid application gets compiled, it creates a binary, and this binary is for the Android platform, and this binary will upload and run all these assembles. And in the assembles folder, we can find the Mono DLLs and application DLLs and whatever DLLs we need. And all these in the assembles, we will find all these .NET libraries. Windows.NET pretty much libraries there in the assembles. But the binary will run all these DLLs for you. Then we also have the platform files and folders, in this case for an Android application. And then it also creates a lib folder, and it will include a library. And this library is the libmonodroid library. And this is what it does. This library is the engine, is the framework engine. It will take your .NET code and translate it to native Android code. So it can run so it will translate your code there. So it's the library. So this is also interesting. So this is the structure of a Monodroid application. Then Monotouch, the same thing. I just put it in two categories. It's the same. Monotouch is the same as Monodroid. Monodroid for the Android, Monotouch is for the iPhone. It's quite simple, same thing. And here is the same. We use .NET application and to write apps that works on iPhone, on iOS. So it's the same as Monodroid. Okay, and actually the structure is very simple. Again, we have a platform binary for the iOS. and this binary will run the application name. Here, app name, it will be the application name. For example, if my application, I don't know, is Acme, it will be acme.x or something like that, whatever. So here, instead of folders, for the iPhone, all the files and DLLs and everything is in the same folder. So when you look at an iPhone, when you're doing, for example, a reversing of an iPhone application in Monotouch, you will see all the files are together. So here we have the binary. The binary uploads the executable. It's a .NET executable, and this exe will run all the DLLs it needs. And we will find all this. Again, we have the mono DLLs, the Shimian DLLs, and the application DLLs, all these DLLs the application needs. And we can find them all together. So quite simple, very similar to the mono-Android. In this case, we don't have the library like in the Android because all the things how to run and translate all the code is in the binary. So that's the reason we don't have the library here. Okay, so now we have taken a quick look on the different technologies, and now we will take some tips on how to review those kind of apps. I mean, it would be more like from a reversing point of view, because chances are you will not get the source code. Or in some cases you can, and we will show you how. But chances are you will assess these kind of apps from a more reversing point of view, right? And that's the idea of this talk. Okay, in case of basic for Android, first thing we want to identify if an app is like just a regular Android app, or is using mobile cross-platform technologies. If it's using any technology, what kind of technology? Very simple. In this case, we just use APK tool. We just decompile the entire APK, the Android application, and we just search for the anywhere folder software. If we find a folder called anywhere software, that's a basic for Android application. And here inside this folder, we can find all the libraries for the basic for Android framework. So if we find this folder, this is a basic for Android. All the applications contain this folder. Another thing we can also quickly fingerprint this application is, for example, if we look for B4A DSA, those files behind at the bottom. For example, if you find those files in the APK in the Android app, this is a basic for Android application. So it's quite easy to spot if this app has been written in basic for Android. One of the interesting things is, for example, as I show you, is we write the application in BASIC, right? And it gets translated to Java. But the interesting thing is, if the application has been published in debug mode, we can recover the basic code. And we have seen this for real in several applications that have been published into the markets in debug mode. And here, for example, we are doing a reversing of a basic for Android application. We are looking on the Java code, but we will only focus on the constant strings. So we are looking for the strings. Actually, we can recover from the strings. We can pretty much recover the entire basic code. So we are getting from the Java. We are trying to get in all the basic code, trying to get in the code that the developer wrote this application. So it's quite nice. And I said we have seen this for real in several apps that have been published in debug mode instead of release mode. So it's quite interesting. We can get all the basic code, right? And another thing we can also do is like for this basic for Android for the interface for the UI, it creates like several files called BAL files. So what we can do is, for example, if we have downloaded the basic for Android development environment, we can use the tools to perform the reversing. And instead, for example, of running this application, we can just take all these BLL files, and thus we can run those files in the basic for Android designer. Is the tool used to design all the UI, but we can do the opposite. We can upload these files into the designer, and then we can get a feeling of the application without running. We can see all the different schemes without running the application. So that's quite nice. We can get an idea of the different schemes of the application. Okay, so that was quite basic for Android, and then for the rest of basic for Android is just like a regular Android. So you will do the same thing as doing a review for an Android app. So nothing much more there. In term for the PhoneGap, same thing. We want to spot if we want to identify if this application has been developed in PhoneGap. So we just look for the www folder. That's easy. We see this folder and we look inside this folder, and it contains like HTML, JavaScript. And so it will say like you will also see maybe a PhoneGap JavaScript file or a Cordova JavaScript file. That's a PhoneGap application. That's easy. And the interesting thing is, we look into this folder, we can get the entire logic of the application. So everything is like in clear text, and we can make. And another thing is we can make changes. Actually, you can, for example, you have a PhoneGap installed in your application, in your device, and you can modify. You can have access to this folder. You can make changes to the application to these files, and that's fine. There's no any signatures or anything like that. You can make any changes to this file, and it will run fine in the phone. So for example, if you want to create, there are some people making commercial application in PhoneGap, but I don't know, pretty much all the applications are free, because you have to think about it that anyone getting access to this folder can get the entire logic of the code. So if you want to write like sensitive applications, maybe this is not the best solution, but it depends what you want, right? No, so now we are looking for the PhoneGap review, right? One of the first things we want to check is what the permissions. As I showed you before, we have a lot of different permissions. So we have to make sure, we just want to review how many permissions the application is using. Then we have the configuration file, and here we can just look for the config XML, and then we can look for the plugins, what plugins the application is using. We can also look at the access origin. If the access origin is a star, like there, that means that the application accepts any input from any domain. So that's quite. This is a security risk, because it can have like cross-site scripting attacks if the application allows this. And that's actually most of the PhoneGap's application use access origin start, and that's very common, and there's a security risk using this. Then we can also look into the JavaScript code. We can look for sensitive information. Is there any passwords there? Use on insecure syntax. Cross-site scripting is quite, actually cross-site scripting security risk is quite common in PhoneGap's application, because at the end it's just a web app application. Is the application using clear text channel, HTTP, etc. So here we have different things we want to look for when we're doing a PhoneGap review. And in this link you will find more information about it. Fingerprinting a Corona, again, the entire application gets built into a resource.car file. So we find this file, that means it's a Corona SDK, and we also, in the case of Android, we can find this lib folder with liblua, libcorona. So now we know this is a Corona application. It's easy to spot. For how to review this, right now it's a bit hard, because, for example, the resource file, the resource.car file, so far we have not been able to really find a really nice tool to reverse that. So we are working on that, on a proof of concept to reverse that, but it's not working, and that's the reason I'm not showing you. But we're working on that. So it's just a matter of time we are able to reverse that file. But for example, if we just xdump this file, we can get a lot of information, like the names of the Lua files, and we can get a very good idea. But right now it's just like a bit manual to reverse this. Can be done, it just take a bit more time. Right now, I haven't seen any good tools to perform a Corona review, but it's in progress. For the raw mobile, same thing. How we want to fingerprint this kind of apps? Easy. For the iOS, we look for the ROM runner. That if we find this binary, and all the applications in the iOS. In raw mobile use this binary name, so we find this raw runner, and we also find a folder called apps that inside we can find the ROM config. That's our raw mobile application. So easy to spot. And then we can also find a lot of ICQ files. The ICQ files, those are the entire Ruby bytecode, their files. And for Android, same thing. We look for the lib folder, and then we can find the lib routes library. We can also look for the apps folder, and inside the app folder, we can find the route config file and folders like app, lib, and public. And that will tell us this is a raw mobile application. For when we want to review this application, we look for the raw config text file. So we look for this file. And actually, we also want to reverse all these ICQ files. The same thing, I have tried several Ruby decompilers, but so far none of them are working for us. So we are still working on this, how to decompile this kind of files, but it's just a matter of time we are working. And right now we are also working on a tool to decompile these ICQ files. But the entire application gets compiled into ICQ files. But actually you can edit those files and get a really good idea using the Ruby instruction set in that link when you are reversing those ICQ files. For the root config file, as I said before, all the applications get a row config, and here we can find the URLs, even some passwords maybe. Depends. We can all the applications, raw mobile applications in your device install a HTTP server. But so far, from where we have seen, this server only works in the local IP. But who knows? It also says in the documentation this HTTP server should be only enabled by debugging, but when you are developing, and never in production, right? So when we are reviewing this file, we have to look for this file. I mean, is there any passwords? If the HTTP server has been enabled or not? Where are the logs going? You can also define here if the logs are going to stays in the device, or he also sends the logs into a server. So we can get all this information from this raw configuration file. And here we can find some interesting pieces when we are doing a review of a raw mobile application. For fingerprinting, a mono droid, mono touch, same things. We look for all the DLLs. I mean, for example, we are doing a reversing of an application on Android and iPhone. We see a lot of DLLs, mono DLLs, Xamarin DLLs. That's a mono droid, mono touch application. So quite easy to spot these technologies in a mobile app. How do we want to review this? I mean, this quite easy, right? I mean, it's .NET. I mean, we have been doing .NET reversing for a long time. I guess many of you are really familiar with it. So it's just a regular .NET reversing. So we just take all these DLLs and use different tools that like the compiler disassembles, and then we can get the entire code of the mobile application there. For example, when we were looking around different applications, and we found this is not like a security bug per se. It's like more. We thought it was quite funny, and we were looking around and we saw the WTF. I'm not gonna say it, just not to offend no one, but you guys know what that means. And we saw that priority in the log, and we thought that's quite interesting. Actually, Hyena is a public framework, so we look the original code, and this WTF was not there. So that priority has been included into the application by the developers, I will assume. And the funny thing is, when an error in this application, when an error happens, and it has the FTF priority, two things happen. One of the two things. It will save this error message to the device, or it will send it to a server in clear text in HTTP. And actually, if you get this error, for example, you are running this application. I'm not going to give you any names of the application just in case, but you can figure it out quite easily. But if, for example, if this error happens, it will not, for the user, it will not tell you it's taking this log and sending to so it's completely transparent for the user. So, but we thought it was quite interesting and to have this sense of humor for the developer, right? Okay, one of the things that caught our attention is none of the application we review use obfuscation. And we have seen 2 frameworks that support obfuscation, but none of the applications were using obfuscation. So I don't know if people, because I guess it's not enabled by default, and others is because the developers doesn't know about these features. I don't know, but it was quite interesting that none of the applications were using this security layer, right? Okay, for the vulnerabilities, one of the things at the end we just found that common. At the end is just same things as a regular mobile app in Android or iPhone, right? We pretty much found the same issues. We found clear text communication, weak cryptography, using insecure libraries like Bulma, a very high risk vulnerability right now that many apps has the vulnerability at the moment. Sending sensitive information to the SD, the entire application logic is exposed. For example, in the phone gap, you can get the entire application logic, insecure passwords, JavaScript injection. So these are, here we can see a lot of security risk, and you can also see that I have put there the OWASP mobile risk number, and we think about it, the OWASP mobile risk, and this is all the criteria, the top 10 risk for the mobile, is like, I think 2-3 years old now, yeah, 2-3 years old, and we still see this kind of security risk still, even in this all kind of mobile cross-platform technologies, still suffer the same risk as a regular app. So now when we're looking for bugs, now we have the native application binaries, libraries, but now we also have all the cross-platform technology, right? We have the cross-platform applications, libraries, configuration files. So now the attack surface is quite wider. So we have more chances to attack an application. Because we have the native application, and then we have the cross-platform technologies as well. So the attack surface is wider. And now we are finish up. So some conclusion. Another thing we just found, we thought was quite interesting. Of course, how we find this application? We went to each website and went to the use cases, and we start downloading those apps, right? One other thing we found is like several use cases doesn't use this technology at all. And it was several apps that they were publishing, they were announced using this technology. When we downloaded, it was just a regular Android or iPhone application. So that was quite interesting to see that. I don't know if they were tired of this technology and they switched to a native application. I don't know why, but they were not using this the cross-mobile technology at all. And it says in the website that it was a use case, but in reality it was not. And that happened to several applications we review. So I think it was quite interesting to see that. Next steps, right? So this has been quite manual work, and actually. For sure, we need more reversing tools, much better, especially for raw mobile and Corona. And for example, we are working on that. And actually, we want to automatize. We are writing some tools to automate that and fingerprint. For example, when we are downloading an Android or an iPhone application, to fingerprint an application to know what technology is using and do an audit, everything automatic. Unfortunately, I cannot show you that because the tool is not working properly, but we are working on that. It's just a matter of time. We have a proof of concept working on. But right now it's quite manual, but it's not easy. I mean, it's quite easy to do, but it just takes time. So we want to speed up things. So to recap, the cross-platform technology. So depending on the technology, it's a bit more hard to reverse. So we have seen several examples. The Ruby and Lua mostly are right now a bit hard because there's no any really good, or we have not found those tools at least to reverse to decompile Ruby bytecode on Lua code. So it's not. So it's a bit more hard at the moment. We can see also they suffer the same bugs as a regular application and native apps. So we have seen all these kind of security issues from the OWASP list before. And so far, in general, they don't offer much more security at all. So that's pretty much the talk I have. You guys have, I think I have, I'm not sure if I'm time. No, I think I'm a little over. No, I think I'm fine. So you guys have any questions, please? Sure.
Speaking about obfuscation and in particular .NET side, you said nothing is obfuscated. You meant that platforms are not obfuscated, or is it possible to obfuscate the software made to those platforms, like Android or Touch?
No, they are not impossible to obfuscate. What we saw is that none of the apps were obfuscated, so none application. In the case of Monotroid and Monotouch in .NET, I don't think so. The developer, you have to download a developer environment, and the developer environment doesn't offer any obfuscation in the developer. I mean, I guess you can do obfuscation, but you have to do it on your own using an obfuscation tool. Yeah. Yes, you can do that, but you have to do it everything on your own. The developer framework doesn't offer you that feature. I guess that's the reason that the apps right now they are not doing that, because there's much work you have to do. I guess many developers don't want to do that. Yeah. Sure.
Have you done any analysis on vulnerabilities or bug that are in the development libraries?
At the moment, we have much focus on the mobile apps itself, and now we start moving to more into the start decompiling all the libraries and all that stuff, because that's a lot of disassemble code, so that's taking a bit more time, but we are working on that. I mean, I didn't want to go into the details of that here, but yes, we are start working on that now. Yeah, to look more into the vulnerabilities. Actually, we have started looking. We have found some issues, but they are not. We have not shown those issues here, right? I mean, we cannot tell everything. Yes.
Hi. I see that you did not speak about the Firefox OS platform. It seems that the applications to develop applications on the Firefox OS platform is pretty trivial. I would like you to share some insight on how could you port the technologies that you're developing into the platform.
Yeah. The reason I'm not going into the Firefox OS is because we have been trying to get a Firefox phone for the last several months in Spain, and so far we have not been able to get the Firefox phone, and that's the reason I have not gone into detail, because we have not been able to get a phone by ourselves. I know some people who have been doing reversing and doing security, and actually all the applications in Firefox OS are just regular HTML applications. So it will be similar to the phone app. Similar. Sure. Well, it will be the same like a regular application in Android. It depends on the vulnerability, right? For example, in JavaScript, you can say maybe vulnerability, maybe a JavaScript attacks to the application in a phone app, for example. It depends on the vulnerability. I mean, some vulnerabilities there's no anything you can exploit, or it's just maybe local things you can do. So there's not much thing. It depends vulnerability. Actually, that's going to change. For example, one of the things in the vulnerability I was showing, Vulna, the name I showed you before, that's quite interesting. That's a vulnerability that many applications right now has nothing to do with application. Vulna is the name of a vulnerability, and you can look it up. It's ads library for getting ads to your application, and actually you can exploit applications used over the network. So, for example, if you find an application has Vulna, and if, for example, you have access to the same network, you can exploit an application remotely, for example. It depends, the vulnerability. But there are some ways you can do some remote attacks to even to mobile apps.
Hi. Hi. Have you done any research on the Good framework?
Excuse me?
Good for enterprise.
I don't know that one. I mean, I know there. I mean, for looking around, when we start looking at this, we count like 40, 50 frameworks. So we decided just to focus on the things we thought is the most popular. So that one, I'm not familiar with that one.
Okay, thanks.
Are you using that one? Okay, it's happy or no? I mean, if it's popular, just let me know and we will take a look for sure.
You did mention that most of the frameworks were equally vulnerable, but any special functionality of the framework which made it more vulnerable? Anything worth mentioning?
Excuse me, I can barely hear you, sorry.
Can you hear me now?
Yeah.
Yeah, you mentioned that most of the frameworks were equally vulnerable, but was there any specific framework which was offering you something to, simplify the implementation, but ended up being vulnerable? Anything special that came up?
In terms of security, they don't offer much features. I mean, for example, only maybe the raw mobile framework has like different security features, so that's excellent. But at the end, it's not like they're not going to give you like a real solution. I mean, at the end, it's up to the developers to write secure code at the end, right? So that's the reason. At the end, all these frameworks, the security they got is the security of the platform. I mean, for example, if I write an application, it doesn't matter the technology I use. The security is as good as the platform itself.
Okay, thank you.
Thanks. You mentioned several tools they can generate. Sorry. You mentioned several tools to enable cross-platform mobile apps where the source code are written in, say, C#, Basic, and so on. Do you also see a possibility of translator tools, for example, accept apps written in Android apps written in Java, and translate and produce target apps to run in other mobile platforms?
I think I'm not understanding your question.
All right. Several tools that you mentioned actually takes a language, application written in Basic or C#. Yep. Do you think there's a possibility of another tools that something like more on a translator tool? They accept native apps, Android apps written in Java, for example, and translate and generate apps they can run on other platforms, for example, iOS.
Well, I mean, the basic for Android takes basic code and translates it to Java. That's the only one so far I have seen. Maybe there's another cross-platform technology. I mean, I didn't look all the cross-platform technologies. Maybe there's one that takes a language and translates it to Java. So far, the only one I know is the basic for Android. The others is completely all the other frameworks. You write the application in the language itself, and it gets interpreted but it doesn't get selected to Java. So far we have only seen one framework doing that. I mean, I guess you can do it, but all these frameworks, they are not doing that at the moment. I guess I am on time. I mean, you guys want to? I mean, I will be here all day, so you guys feel free to talk and stop me by and talk. Thanks a lot.